Hi everyone, in this video I will talk about the concept of sampling distribution or the distribution of your samples. Okay, so the topic for today is sampling distribution. Okay. To talk about sampling distribution, let me go ahead and give you an example. So in this example, we imagine we have a really small population. This is not an example, but this is a population that we have. Okay, so we have a small population. Okay, very small, but it is a population. Okay, is a small population consists of 4 people: Amy, Ben, Connie, and then Danny. Okay, and then in this case, the parameter of interest, it's number of movies they watched last week, right? How many movies they watched last week? Okay, so this is the parameter of interest, or the population parameter of interest. So Amy watched 0, Ben 2, Connie 6, and Danny 6. Okay, and this is our population, small one, and this is our population data, and the parameters, how many movies they watched last week. Okay, good. So let's move to here. What I'm going to do next is I want to show you a histogram to demonstrate these data. Okay, so what we're going to do here is our population histogram. Okay, population histogram. And then for the x-axis, we have 0 movie, 1, 2, 3, 4, 5, 6. And then in here, let me put in the frequency of number of people. Okay. So, okay, let's do 1 and 2. Okay, so come back here. Amy, 0. So there's 1 person watched 0 movie. Okay, so we're going to do here 0 is here. Do this one. Okay, right? 0 movie, 1 person, and then 2. 1 Ben. Ben watched 2. So Ben is 2. Oops. Draw it from the bottom. Okay. Not very accurate, but it's 2, right? It's the range of 2. Okay. 2 movies, 1 person, and then 2 people, Connie and Danny, they both watched 6 movies. Okay. So we have 6. Okay. Right? So this is our population histogram. 1 person watched 0 movie, 1 person, 2 movies, and 2 people watched the 6 movies. This is our histogram, population histogram. Okay. And then now let's assume that we have no information of this population. Okay. So we're going to put this aside. Okay. Let me just erase this. So take notes of this here, and then we're going to erase this and assume that we don't know the population. Okay. So now, from now on, same example, but assume we don't know our population. And then what we're going to do, we're going to use sample, right? It's the sample from this population. You can imagine these 4 people are in a black box. We're going to pull from it. Okay, I'm going to use sample to estimate the population. Okay, that's the goal. And yes, how we're going to do this So the method, we're gonna pick from this, say, black box with 4 people in there. We're gonna pick 2 people randomly. With replacement, right? So we're gonna pull it out, put it back, and pick another one again, and then we're gonna take the average of the 2, and take average of the 2. Okay. When we do this once, pick 2 people, take average, we have 1 sample point, 1 data point, right? Because we have 2 people, take average, 1 data point. Do it again, second data point. And it depends on how many times we do it. We'll, so the more we do it, the better estimation we'll get. Okay. And then before we go into that, we want to ask the question, how many possibilities, how many combinations we can get? Here we have 16. So we have 16 possibilities. Okay, we have 16 possibilities, and let me explain to you why. We're picking 2 people here. Okay, so I want to keep this graph here. So let me erase this side. Okay, so let me write all the possibilities, right? So because it's with replacement, you can get the same person twice. So in this case, we have AA, AB, right? Amy, Amy Ben, right? Amy Connie, Amy Danny, okay, and then, right? I'm just writing out all the possible combinations. Okay, so what I'm going to write next to it, it's when you get these 2 people, you know, they might be the same person, and what's the average between the 2? Okay, so you get 0, 1, 3, 3, 1, 2, 4, 4, right? So you're gonna just add the 2 up and then divide by 2. Okay. Next column. CA, CB, CC, CD, DA, DB, DB, DC, and DD. Again, same thing, 3, 4, 6, 6, 3, 4, 6, 6. Again, this value just you substitute and then divide by 2. Okay, cool. So there are 16 possible combinations, and then what are the possible values that you will get for the sample mean, right? So what are the possible sample mean values? Okay. So the possible sample mean values are, so X bar can take on the value 0, 1, 2, 3, 4, and 6. And then what I want to mention here is that X bar, let me use the red pen here. Yeah, let me use this space here. It's our sample mean. And this sample mean, 2 people, in our case, this is a random variable. Because we don't know it until we have these 2 people put out from the black box, right? So this is a random variable here. Okay. And because they're random variables, each of the possible outcomes for the sample mean has its probability of it happening. Okay. And let me see how I will do this. Yeah. So I'll use the space here, and here to write out all the probability of each single possible outcomes. Okay, so I'm going to use the space here and the space here. Okay, the reason is I want to keep the histogram here. Okay, so what's the probability of getting an x bar equals to 0? Okay, what's the probability you get that? So there's 16 possible outcomes, and then one of them is 0. So this one is 1/16, right? So it's only this one here. Next, what's the probability x bar equals to 1? So how many of them? You have 1 and 2. You have 2 on 1. So we're going to have 2/16. Okay, good. And then probability x bar equals to 2. Probability of x bar equals to 3. Okay, let's do this. How many 2's you have? You have only 1 here. Okay, so it's 1/16. How many 3's you have? You have 1, 2, 3, 4. So 4/16. Good. And then let's do probability 4. Yeah, we're doing here. Bar equals to 4. And then the probability of x bar equals to 6. Okay. Okay. So 4, you have 1, 2, 3, 4. Again, you're 4/16, right? So I'm skipping 5 because there's no 5 here, right? 5 is not a possible outcome of this random variable. So this one is no 5. And how many 6 we have? 1, 2, 3, 4. Again, 4/16. Okay. So following this method of choosing 2 people and then take a sample mean, we have 1, 2, 3, 4, 5, 6. We have 6 possible outcomes, and in each one we attach probability to it. Okay. So now I want to talk about the concept of sample distribution. So I'm going to do it using this histogram here. Okay, histogram here. Use this bar. Okay, this. Okay, so 2. Okay, right. So this one, it's our sampling distribution with sampling 2 people, right? Okay, so we're gonna pick out 2 people and we'll get the sample mean. And this is the sampling distribution with sampling 2 people. And then the values here. Yeah, okay, cool. So x-axis are still how many classes? Oh no, how many movies, right? Movies. And then the vertical line, I'm going to write is the probability of getting that value. Okay, it's the probability of getting a value. And the possible line is 1/16. Yeah, so the minimum is 1/16, 2/16, 3/16, and 4/16. Okay. Okay, so we're gonna plot the histogram using the values we have. 0, the probability is 1/16. So 0, took the value of 1/16. and then x bar equals to 1, 2 over 16. 2 over 16, right? So 1 would be, and then 2 is 1 over 16, and then 4 over 16. I'm going to do them both at the same time. This one is 1 over 16. And this one's all the way up to 4. Approximately here. 16, okay. And then 4, again, is 4 over 16. The values again here. 4 over 16. And then for 5, it doesn't get a bar here because there's no probability attached to 5. So this one is empty. And then back to 6. So 6. Okay. And this is our sampling distribution, right? So this histogram tells us that what is the probability of each single possible outcome for our random variable sample mean. And in this case, the way we get the sample mean is by sampling 2 people or picking out 2 people from a population and take the average of these 2 people. Okay. And this is a graphical demonstration of the sampling distribution. And these, what we have at the bottom here, are mathematically and algebraically to demonstrate your sampling distribution, right? You have each single possible outcomes with their probabilities. Okay, so both represents our sampling distribution. Okay, good. Perfect. Now I want to talk about what are some possible related questions you might get related to this topic. Okay. Possible related questions. Okay, let's ask the first question. What is the chance or what's the probability that your sample mean will equals to the population mean? Okay, what's the probability here? Okay, so let's get this value here. So we imagine that we know the population for a minute and then we'll come back to it, right? So in our case, the mean equals to 0 plus 2 plus 6 plus 6, right? So we know these 4 people divided by 4 equals to 3.5. Okay. So what's the probability that these two will equal? Note, right? For our sample mean, the random variable can only take on 0, 1, 2, 3, 4, and 6. So you would never get to 3.5 if you only looking at the x bar here, right? So the chance in this case for you to get exactly to be the same is 0. Probability of x bar equals to mu is equal to 0, right? So in this case, you can never use your sample mean to get the exact mu, okay? 0 in this case. But we can ask the next question. Okay, the next question is, what's the probability that your sample mean is greater than mu? Okay, so what's the probability that the sample mean you have is greater than the population mean? So let's calculate it. Probability of x bar greater equals to 3.5. Okay, So what is the probability that you get this? So you have x bar equals to 4 or x bar equals to 6. So if you get these two values, then you'll be able to get what you want in the statement here. Okay. So in this case, it just equals to the probability of x bar equals to 4 plus the probability of x bar equals to 6, right? So if you get these two values, you get the statement that x bar is greater than 3.5. This equals to 4 over 16 plus 4 over 16, and this equals to 1/2. So 1/2 of the time that your sample mean will be greater or equals to the population mean. Okay, let me do one more. Okay. So the third case is x bar in the range of 1.5 and 5.5, right? So what is the probability that your sample mean is in between these two values? So if you write it in terms of probability statement, so 1.5 x bar is then 5.5 question mark, right? So what's the probability that your x bar is in between these two values? And what are the values that satisfy this statement or this range here? The values are x bar equals to 2, 3, or 4, right? These three values would do the work here. So this statement equals the probability of x bar equals 2 plus probability of x bar equals to 3 plus probability of x bar equals to 4. Okay. So we just attach the probability to them. 1 over 16 plus 4 over 16 plus 4 over 16, and that's equals to 9 over 16. Okay, so the probability of 9 over 16 that your sample mean will be in the range of this value. Okay, so what these three questions or three examples did is, once you have the sample distributions, you'll be able to answer the questions such as what's the probability that you get a certain value for your sample mean, and what's the probability that your sample mean is between the range. Question like these. Okay, good. Before we end this video, I want to talk about one concept here. Okay, so when we do the histogram, when we do the sample distribution, in this case, we choose to pick two samples. I mean, two people for each sample point. As you can see, the histogram we got is not very normal or not very smooth. So, but we can easily increase the number in each data point, right? So we can do 3, 4, 5, or hundreds, okay? And then how many numbers in each sample point or data point you need to have a smooth normal distribution, that's our next topic or next video. Okay, thank you for watching. I'll see you in the next video.